Okay, so here we go. Section 3.2, angles and parallel lines. This section is a sorry, just bumped the microphone. This section is a really important section. We're going to use this for the rest of the chapter and some of these things for the rest of the year as well. I feel like I keep saying that every section, but it does. I mean, there are certain sections that just pop up over and over and over again in different ways. So angles and parallel lines. We talked about angles yesterday with transversals and those corresponding alternate interior, alternate exterior, consecutive interior. That's it. Yeah, on those angle pairs yesterday. So today we're going to do the same thing working with those. But this time the key is lines are going to be parallel. And if the lines are parallel, something special happens. Okay, I've got it right here where these two lines are parallel. Here's the transversal cutting through. I know it kind of gets all overlapped on top of each other, but hopefully up here I've got it labeled where 1 and 5 are corresponding angles, 2 and 6, 4 and 8, 3 and 7. And notice that the corresponding angles are congruent. 1 and 5 are congruent. 2 and 6 are congruent. 3 and 7 are congruent. 4 and 8 are congruent. So if two lines are parallel, the corresponding angles are congruent. Now, unfortunately, we can't prove that. It's one of these weird things of we just take it as being true, so it's a postulate. And it's the first postulate in the chapter, postulate 3.1. If two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent, because each pair is singular. Now, the thing is, once that's true, once you know that each pair of angles is congruent, well, you know that 1 and 7 are congruent because they're a pair of vertical angles. So if I just dot those real quick with my highlighter, so we'll say, okay, we know 1 and 7 are congruent because they're vertical angles, and 7 and 5 are corresponding angles. Well, hey, 1's congruent to 5 as well, which you see in the drawing here. 1, in this case it's 7, 1 and 7. Hey, the alternate exterior angles are congruent. So not only are the corresponding angles congruent, but so are the alternate exterior. Hey, if we go a little further, and I erase this, go back to the fact that, talk about corresponding business, 1 and 3 are corresponding, 1 and 7 are congruent by vertical angles. Hey, 7 and 3 are congruent. 7 and 3 are alternate interior angles. Look at the drawing. The 3 and the 5, the alternate interior angles, or the 2 and the 8, alternate interior angles, are congruent. The last one, besides corresponding alternate interior and alternate exterior that are congruent, really aren't congruent. What they are is the consecutive interior angles. And unfortunately, they're not congruent, but the consecutive interior angles do hold a special relationship. If you look at 7 and 6, if I take, in my calculator real quick, I should have set this up in the drawing, but I didn't. If I add 118.58 plus 61.42, hey, look at that. The consecutive interior angles aren't congruent, but they are supplementary. And other than one theorem, that's it for the entire chapter. Or section, sorry, that's it for the section. So, I skipped this a little bit. So parallel lines and angle pairs. Parallel lines and angle pairs. So, so alternate interior angles theorem. If two parallel lines are cut by a transversal, then each pair of alternate interior angles are congruent. So 1 and 3, 2 and 4 in this case are marked as congruent. This one here, consecutive interior angles, 1 and 2, or 3 and 4. I don't know why they didn't mark them. They're not congruent, but they are supplementary. Okay, so alternate interior, congruent. Alternate exterior, congruent. So 5 and 7, 6 and 8. So first example for this, okay, kind of one of these solve for X style problems. Let me pull up my presenter. There we go. So we are supposed to solve for X in this problem if we're given this information. Is this the one I'm looking at first? Sorry, I'm kind of all over the place today. Metro 1. Yeah, here we go. So our real question is, what are these relationships? Well, if I look at 1 and 2, let's say I compare 1 and 2. Angles 1 and 2. Here's angle 1. Here's angle 2. 1 and 2 with the parallel lines being A and B, because that's the pair of lines that they're a part of, and then C has to be the transversal. Okay, and then A and B are the parallel lines that are marked. We know that 1 and 2 are a pair of alternate interior angles. So we go back and say, okay, what's special about alternate interior angles? Well, by our theorems, alternate interior angles, hey, they are congruent. So that means for us in our problem then, angle 1 has to equal angle 2. So 9x plus 6 has to equal 2 times 5x minus 3. 9x plus 6 equals 10x minus 6. I would say subtract 9x and add a 6. We get x is 12. Now the problem also has this angle 3 in it. I didn't do anything with angle 3, but I can work with angle 3 as well, and we'll just verify the answer we got. The key is that angle 3 here forms a special angle pair type with angle 2. Angle 3 and angle 2, they are a pair of corresponding angles. And we already said that corresponding angles had to be congruent, so 2 has to be congruent to 3. So a measure of angle 2 now has to equal measure of angle 3. So to solve for y, that's what we're doing in this case, we're going to have to solve for y. Well, we know that measure of angle 2 is 2 times 5x minus 3. Measure of angle 3 is 5y plus 14. Now the problem here is, I don't know, I have an equation with two variables with an x and a y. However, that's not a big deal because I can plug in for x 12. Okay. So I'll get 2 times 5 times 12, well that's 60 minus 3 equals 5y plus 14. That becomes 57, so 104 equals 5y plus 14. Subtract the 14. 90 is 5y, divide by 5. Y equals 18. Okay, so y is 18, x is 12. All right. Okay. So real quick. Okay, I apologize for the weird edit there. I had to pause something real quick and there's noise in the background. I had to cut out. So anyway, so we got this part here where we got our solve for, go back. We solved for x and y in this problem here. Now we have one theorem left in this section. It's called perpendicular transversal. Okay, and hopefully it's kind of an obvious theorem that if in a plane, if two lines are perpendicular to one or two parallel lines, then it's perpendicular to the other. Okay, so if I just kind of go to the drawing real quick here. So what we're saying is this: I have two lines that are parallel first. Okay, so we have two lines that are parallel, and we know we have a second line, or a third line, excuse me, that it is perpendicular to one of them. The relationship then is this: if it's perpendicular to one line, okay, this we'll call it angle 1, we'll call this one angle 2. Well, angle 1 and 2 are a pair of corresponding angles, which means then that also has to be a right angle. So if you're perpendicular to one line, it has to be perpendicular to the second. And again, I kind of straight that again. I hope that seems obvious. Take two lines, draw a line that cuts through both of them, but is perpendicular to one of them. Well, if they're parallel, if he's perpendicular to one, he's going to have to be perpendicular to the other one. Because if this is 90 degrees, this also has to be 90 degrees. If this is 90 degrees, this also has to be 90 degrees. We keep getting 90-degree angles, so it's going to be perpendicular to both lines. So for homework for tomorrow, okay, given that angle 1 is 94 degrees, so we're talking about this angle right here, find angles 3, 5, and 4, so 3, 5, and 4, and then explain how did you use angle 1 to get that. Okay, I'll see you in class.